Heisenberg proved that it's impossible to know at the same time the mass, the position and the speed of the electron, and the Bohr model use orbits. So according to Bohr, we know x and v at the same time. So the electron is not found on orbit. We ask the question, what is the place of the electron? We said that the electron could not be located. It can take any position. And for a given position of coordinates x, y, z from the nucleus, we can calculate the probability of presence of this electron, and this probability may be between 0 and 90%. The motion of the electron inside the atom can be associated to a wave, and this wave has a wavelength lambda, which is variable according to the position of this electron. So the motion of the electron around the nucleus follow a function that we called psi, which is a wave function. And the wave function psi is given by Schrodinger equation. For a determined position x, y, z, we can calculate psi at this point, but the most important is psi square, which is the probability of presence at this point. So in the modern atomic model, the electron does not have a definite position, and the motion of the electron can be associated to a wave around the nucleus. So the atom, the size of the atom is the distance between the nucleus and this electron. And the electron does not have a definite place. So we cannot locate exactly what is the distance between the nucleus and this electron. So the atom does not have a definite shape. At a given position, mx, y, z from the nucleus, we choose a point or we choose some points. We can calculate the wave function at this point according to Schrodinger equation. So psi square is called the probability distribution function, and it describes the probability of presence or finding electron at this specific location for a given energy state. And as we said, this probability might be between 0 and 90%. So suppose we have electron in hydrogen atom, and this electron is moving around the nucleus. So we calculate the probability of presence of this electron. We obtain a sum of points that give this shape. What is the meaning? If the electron, if the position we choose is inside this shape, that means the electron in question, the probability of presence is maximum. Outside these points, the probability to find this electron is minimum, is practically 0. So we obtain a shape of points where the probability to find electron is maximum, and the shape of these points look like a sphere. Pay attention for the concept. That does not mean we have a sphere inside the atom. I follow the probability of points, the maximum probability to find electrons. So I follow the position of the electron, and these points make a shape like a sphere. But this sphere is not a position inside the atom. This sphere does not exist. So the probability distribution for the hydrogen electron at level n equal 1 wave function orbital, the more times the electron pass by a particular point, the darker the negative becomes. Thus, the darkness of a point indicates the probability of finding an electron at this position. This shape, this form obtained, this form of the probability of points, or this form of points where the probability is maximum, is known as electron density map. What is the physical meaning of a wave function? Suppose we have an atom and we have two positions, the position P1 of coordinates x1, y1, z1, and the position P2, x2, y2, z2. The coordinates are determined according to a center, which is the center of the nucleus. The relative probability of finding the electron at position 1 and position 2 is given by substituting x1, y1, z1 in a Schrodinger equation. So we obtain psi1 for the point P1 and psi2 for the point P2. Psi1 square is the probability to find the electron at point P1, and psi2 square is the probability to find the electron at P2. Suppose the ratio of probabilities is n1 divided by n2. n1 is a number and n2 is a number, and I will suppose that this ratio, for example, is equal to 100. What is the meaning of n1 divided by n2 is 100? That means the electron is 100 times more likely to be found at position 1 than position 2. The probability to find this electron at the given point P1 is 100 times more likely than to find this electron at position 2. This is the reading of the probability of presence of electron. Quantum numbers. So psi is the solution of Schrodinger equation, and the psi describes the motion, the wave motion of the electron at a certain position. Okay, so we talk about coordinates x, y, z for an atom that does not exist at our scale, that exists at the microscopic scale. So x, y, z are, for example, in picometers or in nanometers, because the volume of the atom is very, very small. Suppose we have a person in a building, and the entrance of this building is the center of the building. I can locate this person by giving x, y, and z according to the entrance, which is the center of the building. So when I enter a building, I do not say I am going to person 1 that is located from me 10 meter x, 3 meter y, 5 meters z. The presence of this person in the building could not be by determining x, y, and z. But it's easier, for example, for this person in the building that I say I am going to this person that is found at floor 5 in the apartment 2 in the room 3. So I can locate this person easier than locate it by using X, Y, and Z coordinates. So for the atom, it's not easy to use the coordinates X, Y, Z. We will pass from this coordinates to another coordinates at the microscopic scale that makes the reading of the position of the electron easier, and this coordinates we will call them N, L, and ML. These are notations. Why we called N, L, ML? These are notations. Okay. I return to my example. If I give X, Y, and Z for this person, I can locate him directly, but it's not easy to use these coordinates. If I use the coordinates floor, apartment, room, I can locate this person easier. But I need coordinate 4 because in the room I have 2 persons. So I am going to person 1 or I am going to person 2. For this reason, we pass from X, Y, Z is a 3 coordinate system to 4 coordinate system, floor, apartment, room, and which of this person we choose. So we pass from X, Y, Z to N, L, ML, and I will add another coordinates which is MS. So now the position of the electron in the atom is not located according to X, Y, Z. It's easier, as a conclusion, it's easier to read this position according to coordinates N, L, ML, and MS, and these coordinates are called the quantum number. So what is N? N is the principal quantum number. N characterize the energy of the electron in particular orbit. It looks like N in Bohr theory. The value of N can be integer number. When N increase, the more energy the orbital has. In Bohr theory, we saw when we are distant from the nucleus, the energy pass from negative value to higher negative value, and the maximum energy obtained is the value 0. The energies are defined as being negative as electron has energy equal 0. So the electron is at N equal infinity, so it just escapes from the atom. The larger the value N, the larger the orbital. As N gets larger, the amount of energy between orbitals gets smaller, and we explained this in the previous example for hydrogen and hydrogen-like. So as a conclusion, now we don't use position, we use energy level. So what is N equal 1? N equal 1 is an area. I called N equal 1 from the nucleus. N equal 2 is the second area from the nucleus. N equal 3, I prefer to use N equal 1 is the energy level 1 according to the nucleus. N equal 2 is the second energy level, N equal 3. And pay attention, This energy levels are not positions, are area created by me in order to describe now the position of the electron, or to locate an electron. So this is an, in my mind, N is in the system NL, ML, and MS is identical, for example, to X in the system XYZ. The second coordinates is L, and L is called the angular momentum quantum numbers, or the second quantum numbers. What is L? L describes the motion of the electron in area 1. Suppose I say I have electron in the first area, so I give directly for this electron the coordinates n equal 1. My question, what is the motion of this electron on the level 1? Or in other words, what is the shape of the points obtained where the probability to find this electron at level 1 is maximum? So L describe the shape of the orbital, or L describe the shape of the points where the probability to locate this electron is maximum. The value of L depends on the value of N. In the system XYZ, we say that the electron can take any position around the nucleus. But in the coordinates X, Y, Z are related. In the system NL, ML, and MS, L is related to N, and ML is related to L. So L is an integer number that has a value from 0 to n minus 1. What is the meaning of this coordinates L? Suppose I locate an electron in level 1. I called level 1 from the nucleus, so at level n equal 1. What is the value of L possible? The value of L possible is between 0 and 1 minus 1, so the value of possible L is 0. L equals 0 describe a shape of the motion of this electron. So in this case, L equals 0. Suppose the electron passed to level 2, and I repeat, level 2 as a position does not exist. I called level 2 as energy from the nucleus. So when the electron is at n equal 2, what are the possible value for L? The possible value of L are between 0 and n minus 1. So the possible value of L is 0 or L equal 1. What is the meaning for n equals 0, L equals 0? That for n equal 1, L equals 0. That means if the electron is found in area 1, the motion of the electron follow the shape L equals 0. So we have one form of the motion of this electron. If the electron is at level 2, we have two types of motion. The electron is found on the points on the shape L equals 0, or the electron is found in the shape of points where L equal 1, and for n equal 3, n equal 4. So how many value do we have for L? If the L is between 0 and n minus 1, for n equal 1, we have L equal 0. For L equal 2, we have L equal 0 and 1. For n equal 3, we have L equal 0, 1, and 2. As a convention, instead saying L equals 0 or the shape is for L equals 0, they give, if L equals 0, the shape look like a sphere. If L equal 1, the electron is moving in orbitals like two balloons. So P equal L equal 1. For L equal 0, we talk about orbital S. For L equal 1, instead to say L equal 1, we say the electron is moving in shape P. For L equal 2, we talk about D. For L equal 3, we talk about F. Suppose I locate the electron has L equal 1. So I can say that the electron is moving in points that constitutes two balloons. But what is the real place of the electron now? I don't know. I know that this electron is found in one point of the two balloons. But what is this point? I don't know. So I locate the shape, or I find the shape of the motion of this electron, but this electron could not be located. Describe the motion of the electron on energy level n. If L equals 0, the sum of points or the shape of points is a sphere, so the shape is called shape S, form S. If L equal 1, the electron, the motion of the electron is like two balloons and the shape is called P. If L equal 2, the motion of the electron is called D, form D. And if L equal 3, the motion is follow the shape F. So at level 1, we have one type of motion, L equals 0. At level 2, we have two types of L. The motion L equals 0, the shape L equals 0, and the shape L equal 1. 3, we have 0, 1, 2. 4, we have 0, 1, 2, 3. So what is the importance of these quantum numbers? The importance of quantum numbers in level 1, this is level 1, the motion of the electron follow L equals 0, so the motion of the electron follow S. So what is 1s? 1s2 in the college, we write 1s2, 2s2, 2p6, 3s2. We thought that 1s, 2s, 2p, 3s, 3p are places. No. 1s, that means in level 1, the shape of the electron follow the sphere. So the probability of points to find this electron is a sphere. So 1s is a scan of the motion of the electron if this electron is located in level 1. In level 2, we have two forms. We have n equals 0, L equals 0. So we have the form 2s, and we have n equal 2, L equal 1, 2p. So in level 1, we have two types of motion, motion S, motion P. The scanner of the electron, of the motion of the electron, if found in level 2, is 2S, 2P. This is a scan of the motion. In the college, we ask a question, why in level 1 we don't have 1P? In level 1 we have 1S, we don't have 1P, since the value L equal 1 is impossible in level 1, because L is between 0 and n minus 1. In level 3, the value of L are 0, 1, and 2. So in level 3, we have the three types of motion of electron. 3s, 3p, or 3d. And in level 4, we have 4 types of motion: 4s, 4p, 4d, 4s. So what is the meaning of this figure? The meaning of this figure is this is a scan of the motion of the electron around the nucleus. So this scan is called the electronic configuration. And the electron configuration are not places. The electron configuration are notation, are a scanner of the motion of the electron.